Hiya, I'm Matthew Vickers and this is the robot programme that I worked on. I've actually done this programme again during my work experience on Vauxhall Motors. I've decided to make a presentation out of it and explain the programme. I've also got a few props as well that I'll get into. Now normally again I'd hand out the presentation pack, however what I'm going to do is just pop them up on here again and I'll go through it one by one this time, as I speak quite a bit about this one, a lot more in the laminate sheets than the previous one, or if you've not seen it yet, the pneumatic board that I've done. So I'll just pop them up now. So again, the first sheet is just an introduction to it. Just put that one there. Now the next sheet, labelled X. Now this is a bit of background information about the robot, so what robot it is, and the robot program details, but I'm going to get into all of this, so you can just have a quick glance if you'd like, but I'm going to go into more information and more detail later. So first of all, I'll just pop this up there. However, it's a little bit irrelevant as I do actually have the model here for you. So this is the robot I worked on. It was a 6-axis FANUC welding robot. Now I'll just show you the axis. So this is the first one, the second one, the third one, the fourth one, the fifth one, and you'd have a sixth just on the end here. Now that's the robot I worked on. Now I've actually got that model off Mike Smith. He was the person who I went with through all of this. He was a controls engineer at Vauxhalls and he was a genius, to be honest, the majority of the stuff. Some of it might have went over my head, but luckily I picked up on quite a lot of the basics and it was very enjoyable. I also managed to get this. Now this is another prop I'd just like to go through now. Now this is the pendant. It's a broken one, however this pendant I used a similar one obviously when it was doing the programme, and this is how I controlled the robot. So I'll just pop these sheets up for you here. So that's a picture of the pendant working, and this is a screen which all of the pictures are taken from. This is what it would look like if it was actually working, and it'd obviously be on this screen here. However, because this is broken, I can obviously use it. Now again, I'll pop up sheet H. Now sheet H just shows that the pendant was cabled up to the robot control, and this is how it actually works. So now I'll just take you through some key features of the pendant. So just pop these sheets to the side and pop this here. So this is the pendant I worked on. I'll just take you through some features. First of all, the emergency stop. Now this speaks for itself. Press this button, everything shuts down, and it's to ensure safety if you need it. Now at the back, you've got the dead man's hand. Now this is similar to the emergency stop. When it's gripped, everything shuts down and stops. However, the reason you've got a dead man's hand is that it's proven when electricity passes through your body, you grip. So if it's gripped, then it shuts down, and again it's more of a safety procedure. So how would you find my programme if it was working? First of all, you turn it onto manual, then you click File, you scroll up and down to find my file. Once you found it, I think it was called MV, you'd click Enter, and to run my programme, you click Shift and you can run it forwards or backwards, whatever. Now when you're actually doing the moves in the programme, here you've got 12 buttons. Now you can see it says J1, J2, J3. This is for all the different joints. As I mentioned, it's got 6 axis or 6 joints. Now you can move them forward or backwards. And finally, you've got a speed here. So if the robot was capped to, let's just say 10 millimeters per second, you could increase it as much as possible so it's going as fast as possible, or you could decrease it to half that speed, which would be 5 millimeters per second, 20% of that speed, which would be 2 millimeters per second, and so on. Well, this is the pendant I used. And now, I'll pop this prop back here. I'll get into the actual programme. Now I'll pop this sheet up here. Oh, sorry, I've got my magnet there. I'll just put it on here instead. Now this is sheet A. Now this is a picture taken up front on the pendant, and this is the main programme. Now I'll be referring back to sheet A once I've used other sheets, as I'll be going through bit by bit what everything means. So, first of all, J. J just means the robot's doing a joint move and it's using one of its joints to move. Now P1. This is the position of the robot, so if you look a bit further down, P3 there and P3 there, the robot is in the same position. 100% is the speed, so as I mentioned, if you want to go 100% as fast as possible, and we mentioned, I think if we said it was capped at 10 millimeters per second, then this means that the move is at 10 millimeters per second. And here it's got a fine. Now, you see it says fine here, and then 4 lines down, you see it says CNT 100. Now CNT 100 stands for continuous move of 100. Now these are different types of moves. So if I push that to the side for a second, and just bring this forward, I'll demonstrate to you the types of moves. So a fine move goes from one point to the other, and it terminates at that point. It can be diagonal, it can be vertical, it can be horizontal, but it goes from one point to the other and terminates. Now we mentioned there's a continuous move, and in this case it's a continuous move of 100. Now say you want to get from point, just do that, there we go, point A to point B. We should just use a fine move to get from one to the other. However, now let's say there's an object in the way. Well, now you can't use a fine move to get from point A to point B. So here's where you use a continuous move. Now a continuous move picks out an imaginary point in space, we'll just label that as C, and it uses this point to manoeuvre around the object. So in my one, it was a continuous move of 100. Now 100 means it cuts off as little as that corner as possible. So obviously the opposite end of it, a control move of 1, would be it cuts off as much as possible. Continuous move of 50 would be in the middle, and so on and so forth. Now in my program there wasn't actually a part blocking it or wasn't anything in the way, but I've just used a continuous move to demonstrate that I could use that type of move, and then so I can explain it furthermore in the presentation. So just rub that off now. And now I'll refer again back to sheet A. Now just on the 5th line down here, you see it says spot. Now this stands for spot weld. However, I'll just say as well, I'm not sure if you've seen the video of my robot actually doing the program. However, it doesn't actually weld. Now this is because there's a problem with the water pump or something like that. It was something too technical. However, the robot couldn't actually weld. So what actually happens is the electrodes just touch down on the metal, release, come across, touch down, and then they go to home. But however, let's say it was working, I'll just explain all this here. Now here it says SD equals 10. This is where I refer you to sheet B. SD equals 10 means we go down to 10 and we come across. Now it says 10 millimeters. This means the electrodes were 10 millimeters apart from one another. Now if you wanted it more efficient, you can have them 5 millimeters apart, but it all depends on how thick the metal you have in the middle. And this is a very basic program, so he wasn't thinking about efficiency, so on and so forth. That'd be more for the production line if it was an actual working robot in the industry. However, that for 10 millimeters apart just means the electrodes are that distance apart. Now refer back to sheet A. After SD equals 10, we have P equals 1. Now this stands for pressure. So on the back of sheet B, I'll now refer you to sheet C. Now P equals 1, we just stay at 1, and it says 2000 newtons of pressure. And this is for a 3.3 millimeter thick metal. Now our metal was 3.3 millimeters thick, so we used a pressure of 2000 newtons. Now what was actually quite confusing is, I didn't notice this until I actually laminated the sheets and printed it all out, that the pressure was in newtons, and I still haven't actually had an answer for this, so it'd be helpful if there is one. But myself, I've normally recognised that pressure is measured in pascals or bars, so this was quite surprising for me. However, I'm just taking it into the fact that 2000 newtons for the measurement of pressure that's needed for this metal thickness. Now again, I'll refer you back to sheet A. Now after P equals 1, we have S equals 1. Now, being totally honest, I've not got the most information about these sheets. Normally I just hand them out as I've got to actually address it. If I just dodged it, it might look a bit specific, but we've got sheets D, just want to zoom into that, and you've got sheet E. Now, these sheets, the information was actually stored on the robot control, or the robot PC. Now, all I know about this information is that on there it's information about how much current it needs to pass through the electrode to the weld and how long this current needs to pass through. But there's not too much information I know. This was probably due to me only being there a week, so I was only doing the basics, and it is a very basic program. However, if I was there longer, I could have delved more into this and done more research and information and found out what it means. However, that's all I know on this information for now. I'll throw you back to sheet A. And finally, you've got end distance equals 10. Now this is just the same as the starting distance. It means the electrodes just lifted 10mm apart again. And then the program, as you can see, runs down, does another spot weld, and then returns to home. And that's using all the same steps as I've just gone through there. Now finally, I refer you to sheet F. Now sheet F is a diagram of my program. So you start at program number select, and you select it off the pendant. It does a subroutine, which is weld apart, and then a subroutine of path to home. Now this is a very, very basic program. However, a more complex program may look like this. So you'd start from P&S, then it could be pick up a part, then you could have seal apart, then you could have weld apart, then it could be put the part down, then it could be path home, then it goes to home, and this would be an example of a more complex program. Now, what does a robot have in common with a PLC? Well, what they actually have in common, or how they work together, is that PLCs are used in the robot industry. So, let's say a car is coming through, and we'll use a car because I've done more work experience of Vauxhalls. You've got a scanner which will scan the car, a barcode. When it scans it, it detects what specific car that is. So when it scans it, it sends the information to the PLC. Now the PLC refers to a database in which all the information is stored. So it has a specific code, and a PLC calls this code. So you can have one for a 3-door car or a 5-door car. And then they'd have different welds that need to be done. So it'd call a specific weld, and it'd then speak to the robot, and the robot would then do this weld, what the PLC has told it to do, and that's how it all works. But anyway, this is my presentation. It was a shame again that I couldn't do it face to face. However, I've tried to make the most of the situation, and yeah, thank you for listening.